Hello. So I am going to go over the cardiac cycle diagrams today, and we'll go through this diagram right here, and we will explain all the things in this figure and what they mean. And then we'll go on to a similar diagram explaining the same things, uh, but set up a little differently. And this is the one that you see in your book. So we'll do this. And then we'll finish it off with a little exercise at the end. I will be going over this in a PowerPoint lecture in addition, but this is meant to give you a specific tutorial video on how to fill these out and what the meaning is. So let's start by this cardiac cycle diagram and what it means. And so there's a couple of things here. There's this right here, which is the ECG or electrocardiogram. This right here is heartbeats when you hear them. During the cardiac cycle. This right here is really talking about pressure. So this is pressure in millimeters of mercury, measured in millimeters of mercury. So over here, this is actually millimeters of mercury as a measurement of pressure. And then down here is going to be volume of blood in the left ventricle. And this is measured in millimeters. So over here, this is millimeters of blood. Now below that, we have this area, which is valves. So heart valves, and whether they are open or closed. Down here are phases of the cardiac cycle. So the cardiac cycle has different phases that we call them. And these are kind of diagrams signifying what those phases of the cardiac cycle look like. So what's going on? So I have a list of things that I want you to be prepared to explain. And so one of them is the ECG, the heart sounds, ventricular, atrial, and aortic pressure, ventricular volumes, specifically end diastolic volume, end systolic volume, and stroke volume. I want you to be able to explain exactly where the AV valves open and close and exactly where the semilunar valves open and close, and what's going on during all the phases of the cardiac cycle with respect to diastole, systole, what's going on in the ventricles, the valves opening and closing, and be able to finally explain isometric contraction and relaxation periods with respect to pressure in the ventricles and the valves. All of these things are going on at the same time. You have one heart, and we have different ways to measure what's going on in your heart. One of them is through the electrical activity, and that is your ECG. So ECG measures the electrical activity and that really is measuring the electrical activity as it goes from the SA node to the AV node to the bundle branches, and then finally the Purkinje fibers, right? So it's measuring the electricity. And these ECGs have wave patterns, and these wave patterns are electrical, and whether they're up or down does not signify whether something is contracting or relaxing. It's just the way that the electrical signals are picked up. But we do know, and that's clearly not dark enough, we do know that this first wave right here, called the P wave, is, let me rewrite that, P wave, is when your atria are contracting. Okay, so this is atrial contraction. Another way to say that is atrial systole, right? So it's contracting. The atria are contracting. Then there's a period of delay here. That is where the electrical signal is pausing at the AV node before it goes down the bundle branches, down the interventricular septum. And then we come to this area right here, referred to as the QRS complex. And that is equivalent to your ventricles contracting. And another way to say that is ventricular systole. And then finally, we have this last wave right here, and that is your T wave. It's not as easy to write on these things. So let's see, that is your T wave, and that is equivalent to ventricular relaxation, or another way to say that is diastole. All right, you might be wondering where atrial diastole is. Well, atrial diastole ends up being part of the QRX complex. So the QRX complex is not only ventricular systole, but included in that is atrial diastole. It just gets kind of folded in with that QRS complex. Next thing to go over is heart sounds. So the first heart sound we hear right here, that's the first heart sound, and that's the second, that's the lub dub. So if you're listening to someone's pulse, you're going to hear two sounds. And the first sound is going to be the AV valves closing. Okay, so the first heart sound would be the closing of the AV valves. So AV valves close. And the second heart sound that you hear are the semilunar valves closing. Valves are going to open and close based on pressure changes in the chambers and in the vessels, specifically the aorta. So pressure changes are going to cause AV valves to close, and pressure changes are going to cause AV valves to open, as well as semilunar valves to close and semilunar valves to open. And so that is why we have this pressure graph right underneath the heart sounds, because the heart sounds are due to the pressure changing in the atria and the ventricles. And so we're going to go over that next. So first thing is we have this pressure right here. This pressure line is aortic pressure. And then we come down to this next line right here, and that is atrial pressure. And then we come down to this next one underneath here, and that is ventricular pressure. Okay, so when you're looking at the pressures, first thing I want you to notice is aortic pressure starts about 90 millimeters of mercury, and right about here, I would say it's about 90. And it's going to dip down a little bit and then rise back up. And it's going to rise back up when blood is ejecting from the heart. So when the left ventricle ejects blood, which is this volume here, that's the volume of blood ejecting from the left ventricle, you're going to see the pressure go up in the aorta because the myocardium in the left ventricle is surging that volume of blood through the aorta, so the pressure increases. Going to dip a little here at the diacrotic notch. I'm sorry, I should back up. The diacrotic notch is right here after the semilunar valves close here, and then blood in the aorta bounces off the closed aortic semilunar valve and bounces back up and then goes back down. So that's here. All right. Let's see. Okay, so that's aortic, and let's go through atrial. So atrial pressure doesn't get really very, it's not very high or low, it just kind of stays here. But what I want you to notice is it goes up a little bit here, right as we have the P wave. So that is, again, when the atria are contracting. Atria contracts, and obviously that's going to increase the pressure inside the atria. So you have a little pressure jump, and then the pressure dips. And when the pressure in the ventricles starts to increase due to contraction. So remember, the QRS is when the ventricle starts to contract, right? So it's depolarizing. And you start to have ventricular contraction here. And as the ventricle contracts, it's increasing the pressure in the ventricle here. So that's important to understand, in that the QRS is causing ventricular contraction, which causes a rise in the pressure in the ventricle. And so you're going to see this rise here. Now, the first heart sound I told you is the AV valves closing. When the pressure of inside the ventricle increases right here beyond atrial pressure, that is when the valves close. So the AV valves close due to the pressure in the ventricle now being greater than the pressure in the atria, right? So this causes first heart sound, or AV valves to close. And this occurs, this heart sound here, occurs when the ventricle is contracting, and that's causing the pressure to increase, close the AV valves, and the ventricular wall is contracting because at this point, the bundle branches are traveling, the electrical current's traveling down the interventricular septum and going up the side walls of the ventricle, and it's squeezing the ventricle. And at this point right here, this is the point right here where these semilunar valves are going to open, because at this point, ventricular pressure exceeds aortic pressure, right? So aortic pressure is here, and ventricular pressure is now above it, and it forces open the semilunar valves. And at that point, you're going to see blood ejecting from the heart, right? So this is where blood gets to leave the heart. And if you look down, this is that same period here where blood is ejecting out of the heart, and that is equal to stroke volume. Stroke volume is the volume of blood ejected from the heart during the contraction period. So here's the contraction period, and it ends here, and that is when the blood is being ejected here and here. So that's your stroke volume. Now, right here at this point, ventricular pressure now drops below aortic pressure, which is up there. And so that is when the I better change the color so you can see it. Semilunar valves close. And once the semilunar valves close, obviously no blood is going into the aorta, so the pressure in the ventricle drops because you are now in the T wave, or ventricular diastole, or rest. So the pressure's dropping in the ventricle because no contraction is going on in the heart. Again, second heart sound is here where you hear that, right? And this one is here. It's where the semilunar valves close. Now, pressure is going to continue to drop in the ventricle, and it's going to eventually drop below atrial pressure here, and that is where the AV valves open back up again to refill the ventricles with blood. AV valves open here, and that's where you see, again, the volume of blood in ventricle filling back up. And this is due to the diastolic phase, right? So you're filling back up with blood. Okay, so here's AV valves opening and closing. This is corresponding with the volume here. So again, this is volume of blood in ventricle, and it's in milliliters, okay? And so as the blood's filling back up into the ventricle here, once the AV valves close, so the AV valves close here, close there, that's all the volume you get at the end of diastole. And so that is called the end diastolic volume. Then the heart's going to contract and eject the blood out. So the volume's going to drop in the ventricle because it's being ejected out of the heart. And then when the semilunar valves close here, you're going to have no more ejection, and that is your end systolic volume right here. Now, to find out stroke volume is equivalent to the end diastolic volume minus the end systolic volume. And in this case, you can see it. The end systolic volume is 50, and the end diastolic volume is 120. So it's 120 minus 50, and that would be 70 mLs for the stroke volume. So 70 milliliters of blood is being ejected from the heart during the contraction phase. So a couple of things to note is that you might notice that right here is where AV valves close. And there's where semilunars open. Here's where semilunars close, and here's where AV valves open. Now there's this dark shaded area here, strips showing it. And if you look here, you go all the way up. Hopefully you notice that there is no volume change. The volume's staying the same. I should do it there. The volume is staying the same during this period and during this period. And that's kind of corresponding to these pictures here. That are showing you there's no volume change in the heart. And here's where we get into the heart valves and the phases of the cardiac cycle. So we could say these are AV valves, and these are semilunar. And here the AV valves are open, and the semilunar valves are closed. Here, they are all closed. And so this period right here is called the ISO, meaning the same, volumetric contraction, because the heart is contracting, but no blood is leaving because the AV valves are closed and the semilunar valves are closed. But the heart is still contracting, and that's what those arrows mean. The myocardium is contracting. And of course, this is following the QRS, in which the heart's contracting. It's showing that, of course, the pressure is increasing and building during that period, but no blood is leaving, and diastolic volume is the same. And eventually, the pressure inside the ventricle gets greater than the pressure in the aorta and pulmonary trunk, and that's going to force the semilunar valves open, and blood will be ejected. So that is the stroke volume, right? So blood is being injected. And as that happens, the pressure then changes. So the semilunar valves close here. And the AV valves are still closed during this period. And so what you see are AV valves are closed. Oops, wrong one. Here's AV valves are closed and semilunar valves are closed. And this is the end systolic volume here. And so this is isovolumetric relaxation or diastole. This is your end systolic volume. So this really marks the end systolic volume, and this really marks the end diastolic volume. And if you minus those, you're going to get stroke volume. Now, once here, where the AV valves open, where the ventricular pressure drops beneath the aortic pressure, AV valves open, and here is where you have refilling ventricle during early diastole. And that's where they get into the phases. So here, the AV valves are closed and the semilunar valves open. And here's where these AV valves reopen and the semilunar valves are closed. Here's where they're all closed. Okay, so that's where we tie into these phases. So some books call them, like late diastole because there's filling. And this would be isovolumetric. This is systole. And then early diastole. And there's filling. And different books have different names for phases, and that's not really the important part of this diagram. It's more understanding how all of this stuff fits together. So this is your first series on this diagram, and I will follow it up with a second in the series.